Hi, everybody. It's Professor Mitchell. Today we're starting chapter 1 on linear equations and straight lines. And in this first section, 1.1, we're going to be looking at coordinate systems and graphs. In this section, we'll be looking at the coordinate line, the coordinate plane, the graph of an equation, linear equations, the standard form of a linear equation, the graph of x equals a, intercepts, and finally the graph of y equals mx plus b. And you will probably find that a lot of what's in this section is review of what you've learned in other courses. All right, so we'll start with the coordinate line, also known as just a number line. To make a coordinate line, we choose an arbitrary point O called the origin on the line, and a unit of distance along the line. Then assign to each point on the line a number that reflects its directed distance from the origin. And when they say directed distance, they mean it can be negative. All right, so for example, if you want to graph the points -3/5, 1/2, and 15/8 on a coordinate line, that would look like this. So the origin is 0. Going off to the right, we have positive numbers. Going off to the left, we have negative numbers. And then some people do have trouble plotting fractions on a number line. So think of this as taking the space between 0 and 1 and dividing it into 2 parts. And then 1/2 just goes halfway in between. -3/5, you would divide this space into 5 parts. Let me see if I can do that on here. It's probably not going to look perfect, but something like 1, 2, 3, 4, and then this would be -5/5 over here. So when you count 1, 2, 3, that's where -3/5 ends up. And then 15/8, you might recognize that as an improper fraction. If you need to plot an improper fraction on the coordinate line, it helps to think of it as a mixed number. 15/8 as a mixed number is 1 7/8. So you start at 1, divide this space into 8 parts, and then count up 7 of those parts, and that's where you put that point. All right, next we have the coordinate plane. We construct a Cartesian coordinate system on a plane by drawing 2 coordinate lines called the coordinate axes, and we draw those perpendicular to each other at the origin. The horizontal line is called the x-axis, and the vertical line is the y-axis, as you see here. Each point of the plane is identified by a pair of numbers, a comma b. The first number tells the number of units from the point to the y-axis. The second tells the number of units from the point to the x-axis. Another way that I say this is you start at the origin. The first number tells you how far to move right or left. The second number tells you how far to move up or down. Okay. All right. So for example, if we want to plot the points 2, 1, -1, 3, -2, -1, and 0, -3, that would go like this. So 2, 1 tells you go 2 to the right and 1 up. Okay. A positive x means to the right, a positive y means up. -1, 3 would be 1 unit to the left because it's negative. And again, 3 units up, so that would be right here. -2, -1 would be 2 units left and 1 unit down because the y is negative. And then finally, if the x coordinate is a 0, that means don't move right or left, just stay on the y-axis. And in this case, we will go 3 units down, and we will end up at this point. All right, the graph of an equation. The collection of points, x comma y, that satisfies an equation is called the graph of that equation. Every point on the graph will satisfy the equation if the first coordinate is substituted for every occurrence of x, and the second coordinate is substituted for every occurrence of y. All right, so in this example, we will sketch the graph of the equation y equals 2x minus 1. And I'm going to do a lot of that work on my tablet. So let me switch over to the tablet. Okay, now there are other ways to graph equations like this, but for now, we'll just make a table. So for my x values, I will just pick integers from -2 to 2. Technically, you can pick any numbers you want as long as you have a good enough variety of them. All right, and then I'm going to substitute each of those values of x into the equation, which is y equals 2x minus 1. So what you'll see me do sometimes is just write 2 blank minus 1, 2 blank minus 1. I write the equation without the x, and I guess technically without the y, because I'm about to figure out what y is for each of these. All right, here we go. So 2 times -2 is -4. -4 minus 1 is -5. 2 times -1 is -2. -2 minus 1 is -3. 2 times 0 is 0. 0 minus 1 is -1. 2 times 1 is 2. 2 minus 1 is 1. And finally, 2 times 2 is 4. 4 minus 1 is 3. So that means that this graph is going to pass through these 5 points, -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. And when I switch back to the PowerPoint, you will see. All right, so here's the table we just made, and then the graph looks like this. Notice that those points line up and form a straight line. All right, so this is the kind of graph we're going to be looking at a lot in this chapter. All right, an equation that can be put in the form cx plus dy equals e, which looks like alphabet soup. In any given problem, C, D, and E will be given real numbers. Okay, for example, 2x plus 3y equals 4. That is called a linear equation in x and y, any equation that can be put in that form. All right, so what really makes this linear is the fact that x and y are only raised to the first power. You don't see an x squared, you don't see a y to the fourth, you don't see a 1 over x, you don't see a square root of y, you don't see any of that. It's just a number times x plus a number times y equals a number. All right, now linear equations can come in different forms. The standard form of a linear equation, also known as the slope-intercept form, is y equals mx plus b, where m and b can be any constants. That's if you're able to solve the equation for y. Now, the only type of linear equation that you would not be able to solve for y is one that doesn't have a y in it. All right, and so in the case where your equation doesn't have a y in it, standard form is x equals a, where a is a constant. All right, so every linear equation can be written in one of these two forms. All right, so in this example, we're going to find the standard form of the equations 8x minus 4y equals 4, and then 2x equals 6. So these are two separate problems. Let me go back to the tablet. And we'll start with 8x minus 4y equals 4. Remember, we're trying to solve this equation for y. All right, so the first thing I'm going to do is subtract 8x from both sides. Remember, whatever you do to one side, you have to do the same thing to the other side. So that's going to give me negative 4y equals negative 8x plus 4. And then in the next step, I'm trying to get that negative 4 off the y. So I'm going to divide every term by negative 4. And I'm going to end up with y equals negative 8 divided by negative 4, which is positive 2x. And then 4 divided by negative 4 is negative 1. So the standard form of this equation is y equals 2x minus 1. The other one is 2x equals 6. Notice that that equation does not have a y in it. So the standard form of this equation is going to have the form x equals a. So just solve for x. And that's pretty simple, right? We just have to divide both sides by 2. So the standard form of this equation is x equals 3. All right, and that's going to do it for that example. Going back to the presentation. All right, here's their solution for that. Looks just like mine, except maybe they didn't show quite as much work. That's why I like to, work a lot of examples out on the tablet, because you get to see those missing steps. All right, so now let's talk about the graph of x equals a. So hopefully you've heard this in some other class. The equation x equals a has a graph which is a vertical line, a units from the y-axis. A is a directed distance, so it can be positive or negative. In the case of, say, x equals 2, that is a vertical line 2 units to the right of the y-axis. X equals negative 3 is a vertical line 3 units to the left of the y-axis. All right, intercepts. Intercepts come in two flavors. First, you have the x-intercept. That is a point on the graph that has a y-coordinate of 0. This corresponds to a point where the graph intersects the x-axis. So that's really the reason it's called an x-intercept, is because it's on the x-axis. And similarly, the y-intercept is the point on the graph that has an x-coordinate of 0. This corresponds to the point where the graph intersects the y-axis. All right, so to graph an equation in the form y equals mx plus b, first plot the y-intercept, which is the point 0, comma b, and then plot some other point. And I added a note here. Technically, we're not going to be talking about slope until the next section, but I think you've probably learned about slope before, so you can either use rise over run, or you can use the x-intercept, or you can just substitute some other value for x. X equals 1, x equals 2, anything other than 0, because you've already used that point in the y-intercept. And then draw a line through those 2 points. So for example, if we wanted to use intercepts to graph the point, the equation y equals 2x minus 1, which is the example from earlier, to find the x-intercept, we're going to set y equal to 0. 0 equals 2x minus 1. By adding 1 to both sides and then dividing both sides by 2, you get x equals 1/2. And then to find the y-intercept, let x equal 0, and you get y equals -1. All right, and so the x equals 1/2 is the point 1/2 comma 0, which is right here. Y equals -1 is the point 0 comma -1, which is here. And then you can draw the line through those 2 points. It is sometimes helpful when you're graphing these lines on paper to actually use 3 points. That third point is kind of a checkpoint. If you see those 3 points line up, then you can feel good that you're probably doing it correctly. All right. So you'll see that a lot of my PowerPoint presentations end in a slide called audience participation. So if we were in a face-to-face class together, what I would do is give you a few minutes to try these problems and then maybe bribe people with extra credit to come up and do them at the board. If you are a student in my class, what you can do with these is try one or more of them and then post those solutions to the discussion board, and I'll provide more instructions about that. It's something new I'm going to try this first time. We'll see how it works out. And otherwise, that's going to do it for section 1.1. And except for the summary. So Cartesian coordinate systems associate a number with each point of a line and associate a pair of numbers with each point of a plane. And the collection of points in the plane that satisfy the equation ax plus by equals c lies on a straight line. After this equation is put into one of the standard forms y equals mx plus b or x equals a, the graph is easily drawn. And actually, we'll talk about this later in the chapter, but I think it's actually okay to leave the equation in this form. Your textbook is really big on always putting it in standard form, and I don't think that's necessary. And in fact, sometimes I think it's better to just leave it in this form. Okay, so we'll talk about that later in the chapter. Until then, have a great day, and we'll see you next time.